Awesome. Okay, can everyone see my screen? Should I say loops and debugging? Cool.
Yes.
Awesome. All right, let's get started. So loops and debugging. This lecture is going to go by super fast because hopefully a lot of this is already review. They touched on a little bit about this during the pre-work, but obviously as usual, feel free to interject with any questions. Actually, I just need to block off this one more time. Okay, cool. Put this corner. Okay, great. All right. Okay, so loops and debugging. Today we're talking about a few kinds of loops. Do loops, do while loops, for loops, and break and continue. And then we'll talk a little bit about debugging as well. Although the debugging thing, I think, it's less of a thing that like I talk to you about, and more of like a set of skills that you'll pick up as you do more and more programming. So the first kind of loops we'll talk about is a while loop. And if you think about like what a loop entails, right? A loop basically says to a pro computer, hey, do this thing over and over and over again. And if I was to give that command to a human being, the most important questions really are just, great, if you're telling me to do something over and over and over again, the three most important questions are, when do I start? When do I stop? And what do you want me to do? Right? Like that's just kind of conceptually what we would ask another person if that was the request they made of us. And so for a loop, it's actually very similar too. A while loop requires three things. It requires a while keyword. That just basically tells the computer, hey, I'm going to do a while loop now. It needs a conditional expression that evaluates to a Boolean value. All that means is a fancy way of saying, hey, when do I stop? Or how do I know if I should keep going or if I should stop? And then three, a block of code is basically, what do you want me to do if I keep going? So this is the basic layout of a while loop. We have our while keyword. In parentheses, we have something called a conditional. And then we have a curly brace followed by a block of code. Notice how the block of code is indented by 1 unit relative to the curly brace. Okay, and so what that looks like in practice is that block of code is going to run as long as that conditional in that parentheses. As long as the conditional is true, you can think of that as a green light for a loop to just keep going until eventually it becomes false, or when it's our way of telling the computer, hey, you should stop doing this. So let's look at an example of how that looks. Here we have an example. We have a variable on line 1 we create. It's called count and set it equal to 3. On line 3 we have a loop that says we have a while loop, and the conditional says while count is greater than or equal to 1, right? And so count is greater than or equal to 1. This is harking back to earlier. We talked about how if we see 1 equal sign, it's an assignment, right? But in this case, we're not actually assigning a variable. We're doing a comparison. We're saying while count is greater than or equal to 1. Well, in that kind of a world, there's only two possibilities, right? It's either yes, it is greater than or equal to 1, or no, it's not. That's pretty much it, right? So we either get back a true or a false. And if you think about it in the context of a computer program, it lines up very nicely to this concept of, oh, great, it's just true or false, right? Is it just like, do I do it or not? Like, should I keep going or not? And in this case, what we're saying is if we get a green light, if it's true, right? If count is greater than or equal to 1, we console log out count is, and then we do on line 5 this count minus minus, which is once again a shortcut. It just purely just means let's subtract 1 from count, and then we end our code block. And so what we're doing when we actually run this while loop is when we start, the first thing we'll do is we go to line 3, we check is count greater than or equal to 1. In our case, the answer is yes, because 3 is bigger than 1. And so on line 4, we will console log out count is. We would say count is 3. We will subtract 1 from count, and then we go back to line 3. We say, great, let's check, is count greater than or equal to 1? And the answer is yes, because even though we subtracted 1 from count, count is now gone from 3 to 2. So we console log out count is 2. We subtract 1 from count again, so now count is 1, and we go back to line 3. Right? We say is 1 greater than or equal to 1? Yes, it is. We do the same thing, and we subtract 1 from count, and by the end of line 5, we subtracted 1 from 1, so now count is 0. So then the computer says, well, I haven't gotten a signal to stop yet, let me keep going. So then it goes back to line 3, and it checks, while count is greater than or equal to 1. Well, count is now 0, so is 0 greater than or equal to 1? No, it's not. It's less than 1. And so only at that point does the while loop say, okay, I've reached a false condition, where I reached a situation where my condition is false, and I know when to stop. So now let me console log out count is 1, or sorry, let me now stop this loop and not execute my code block anymore. And so that's why on the right hand corner, top right hand corner of your screen, you see it print out count as 3 and then 2 and then 1 and then finally it stops. It says 0. Make sense? Cool. So make sure I was recording. Cool. So the way the while loop works is actually all a while loop says is it doesn't actually tell you how many times it has to run minimally, right? And so if I have this while loop here, in this case where all I do is I put a false in the conditional value on line 1 there, well, that just means when the while loop starts, it will say, great, let's run a while loop. While conditional. What's the conditional? It's false. Okay, great. That means I should stop right away and not run any lines of code. And so that's why on line 2, the block of code is a console log that says this line code will never run. And in fact, when we run it, nothing will show up. Because a while loop doesn't make any judgments on, oh, I need to run at least once. All it really does is say, great, let me run my conditional. If it's true, I'll go. If it's not, then I'll stop. That's all it's doing, right? So I think someone earlier said they really like the fact that computers don't judge, it just executes. Like it's very, very highly logical. And loops are a really good way to see this, right? A computer makes no judgment. It just says, either give me a green light, which in this case is a true, or a red light, which is false. And then I'll either go or I'll stop. And that's all it's doing. Similarly, if I replace the false with the true and I do this now, this will actually cause probably some kind of computer crash. Or nowadays, computers are smart enough, it'll probably run this a few 100,000 times, like, hey, I think this is an accident. I think you meant to stop it. And in this case, this while loop is going to cause what we call an overflow error, which basically means, hey, like you're telling computer to run something basically infinite times, and at some point the computer just runs out of resources. It says, hey, I think this was a mistake on your part. But this is also a totally quote unquote valid implementation of a while loop. You just need to be a little more careful here. Right? So if you think about the example in this page, the example looks just like what we did in the first page, except we removed our thing at the very bottom after line 5 that subtracted 1 from count. So now we start with count equals 3, and on line 4 we check is 3 greater than or equal to 1, and then we print out count if it is true. Well, if count starts as 3 and it's always bigger than 1 and we never change count, then line 4 is always going to return true. And so when we run this expression on line 4, it's the same as the previous example where we had a true value always in the while conditional. The loop will never stop. And so that's why it's incredibly important when you run these loops is to make sure at some point that you know that this loop will stop. Okay? Any questions on this? For me to read chats, I have to get out of the thingy. No, great. Oh, well, that's annoying. Okay, cool. Okay, so that's while loops. For loops are actually almost identical, except we just change around the order. And with for loops, we actually are a little bit more clear about what we're doing as when you think about it, right? So a for loop also requires 3 parts. We have the for keyword, so JavaScript knows we're running a for loop. It has kind of a cheat, I guess, in our case. We have 3 optional things in the middle, and then 3, we have our block of code. Basically, what do you want me to do each time I run this code? And the 3 optional expressions are called initialization, condition, and final expression. So we're going to talk a lot about what that does. Okay, the initialization is something that's only run once ever in a while loop, or sorry, in the for loop, right? We only run an initialization once, and to my earlier example of every loop just needs to know 3 things: where do I stop, or sorry, where do I start, where do I stop, and what do I do? The initialization is basically where do I start, right? And usually it's meant to define a counter variable. It's the reason why earlier when we talked about like variable naming, we said let I equal 0. That's what all I is. It's an initial variable, right? Start somewhere. In this case, we start at I equals 0, I equals 1, I equals really anything. It doesn't really matter. It's just where do you want to start. Then we have our condition. And the conditional here works the same exact way as the conditional in the while loop, right? All it does is it evaluates an expression and it's either going to tell us true or false, yay or nay, like should I stop or should I keep going. And then after each check, we run our block of code, and then we run what we call the final expression. And all the final expression does is it actually updates or it changes our initialization variable in some way. So probably a little bit easier to explain via example. Here on line 9, the initialization is just let I equals 1. And all we're doing there is saying, great, let's start a counter at I equals 1. That's pretty much it. Right? We started counter I equals 1. That's where we started. We just picked an arbitrary start point. The conditional says, hey, let's run the code in the for loop as long as I is less than or equal to 3. And so if that's true, then we run our block of code. And after we run our block of code, then we do this I++, which means, hey, let's change I. How do we change it? Well, let's add 1 to it. After we change 1 to it, we don't ever run the initialization ever again, right? Because we only start the counter ever once. After we run I++, we'll then do the middle part, the I is less than or equal to 3 check again. In this case, we'll say 2 is less than or equal to 3. We'll run our block of code, and then we'll do I++ again. And basically that sequence of events, checking the conditional, running the code, and updating the counter, that just runs in a loop until eventually the conditional becomes false. Right? So this works almost identically to a while loop, except we're just a lot more explicit here in terms of where we start, so the initialization, and also what we do to update the variable. In this case, the final expression, that third part, the I++. In our while loop, we had it in the body of the code. Here, we're just a lot more explicit and say, hey, this is what you do. Right? So conceptually, they work the same way, and in a large variety of cases, you can actually write a while loop or a for loop. Sorry, for the same problem, you can write a while loop as a for loop or vice versa.
I have a quick question on
Yep.
the iteration part, the I++.
Mm-hmm.
Sometimes I get kind of a little confused or mixed up on like when to add the plus plus, like either before the I or after.
Yeah.
What effect?
Yeah. So from a very technical standpoint, the difference is when you do I++ versus plus I, the difference is plus I. I believe. Oh gosh. I believe it adds 1 to the number and then uses it, whereas I++ uses a number then adds 1 to it. Or it's either one or the other, and right now I'm actually not exactly. Actually, I just Googled it. But for this case, it actually doesn't matter too much. So let's do I++ v plus I. That's
like, they're just the same.
No, they're not the same. But their differences is also very it's very nuanced. And in some cases, you actually don't need to do one or the other. Okay, right. So plus I will increment I, then return the value. And then I++ will increment I, but it will return the original value.
I mean, just to chime in, I think it's also, you don't really notice the change until you see what happens to whatever the value of I is in the next line of code.
Right. So the reason why for us this matters a lot less is because whether you use plus I or I++, it's going to run. It's going to change I. Oops, sorry. It's going to change I. And then after it changes I, then we do the check. Where you get in a lot of trouble with this is, let's say I do let x equals 8, right? And I do a return. If I return x, this returns. This should not freeze. Oh, God. Okay, whatever. Great. This returns 8, right? If I do 8 plus, let's say plus I wonder if this is going to make a difference or not. Oh. Sorry. Let I equals, let's say 2. This gives you 11. And then if I do I++, this also gives you 11. Well, actually, you know what? We don't even need x. We can just do this directly. So I++ is going to give you what?
Just do console.log I++. It's going to increment the. So plus I will give you number 3, and I++ will still give you number 2.
You're saying I plus plus will give me number 2?
Yeah.
Great. Yep. So if I go back to my earlier example of this, then I wonder, oh, it's probably because the way REPL runs it. So this is saying plus plus, but then this is doing, so that gives you 11, and then this is going to give you 10. But I'm saying the reason why for us it actually doesn't matter is because let's say I have something like this, right? So right now in a vacuum, 8 plus 2 is going to give you 10, right? If in the intermediary step I do something like this, oh gosh, is REPL gonna? Okay, if I do something like this, right? If I do plus plus I, it's going to change I to a 3, and then when I do a plus 3, it's going to give me 11. But if I do I plus plus, I get the same exact answer. And the reason why is because in this line here, if I do I plus plus or plus plus I, because I'm not using I in the same, because I'm not using I in the same line, by the time it gets to line 4, line 3 would have been entirely ran, and so the I would have been incremented by 1 anyway, right? It's only a much bigger issue if I try to use it like on the same line or like in the same moment, right? So that's why when I do something like x plus I plus plus, now I get 10, but if I do x plus 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 I, then I get 11. So for our purposes, for the purposes of the for loop, it doesn't matter because we're basically changing I, and then only after we change I, then do we use it in our conditional. Does that make sense?
Yeah.
Cool. Okay. So then, if you think about it of a for loop, typically we go from, we have a small index and we keep adding 1 or we go up. But really, like if you think about the way the for loop works, right? Like where do I start, where do I stop, and what do I do? There's nothing in there about like directions. Like I need to only go bigger, or I need to only go smaller, right? I can go in any direction that I want. So in this case, on line 2, we start with I equals 5. I is greater than or equal to 1. I minus minus. This says we start at I equals 5. And then while I is greater than or equal to 1, we keep going our loop. And after every time we run the code block, we decrease I by 1. Similarly, I could either start at I equals 100, while I is less than 300, and I could increment by 100 every time, or decrement by 1,000, or whatever it is, right? Like a for loop, once again, doesn't actually make any specific recommendations on like where you start or where you stop or what you do. It just says you need to tell me what to do, right? So there's no sense of like, quote unquote, like what's like correct. It's just you start somewhere and you keep going until you stop. So once again, computers, very non-judgmental and very just logic driven, right? It's just, this is what I do. And so I'll stop for questions after this slide, but one of the most common use cases for a for loop, you might have already seen this, is just to say, great, if I have a string, which essentially is is an array of characters or a list of characters, if you will. One way to go through every single character in the string is like I start with my index at 0 because every string starts, the first letter of every string is at position 0. And then while I is less than the length of the number, I is less than the length of the string. Here on line 5, all I'm saying is on line 4, let's start at position 0, while the position is less than however long the string is, right? Which makes sense because if I have a string that's 10 letters long, I don't want to look at the 20th position, right? It doesn't exist or it's not useful to me. While I'm still like, smaller than the length of the string on line 5, I grab the letter at that particular index at that position, and I console log out that letter. And after I console log it out, I go to my final expression up there on line 4 on the I++, and I increment I by 1. So now if I do this, I start at 0, at position 0, the letter is A. After I console log out A, I do I++, so now I is 1. Is 1 less than the length of the letter string? It is. So then I go to letters, position 1, which is the second letter, which is B. I print out B. I then go to I++ again, and now I is 2. And I do this over and over again until I reach the very end of the string. And I know I reached the end of the string because at some point I will not be less than the length of the string, and that will tell me, hey, you've reached the end of the length of the string. Okay. Any questions there? Awesome. Yeah, and I know I'm going through a little bit quickly through this, but hopefully a lot of this you've already seen through your pre-work and also just through your own work too. So, I'd rather get you practicing and coding as soon as possible. Okay, two things that you might not have seen. One is called the continue keyword. And what continue does is continue is a reserved word in JavaScript. What that means is it's defined as part of the language. So you can't have a variable called continue. In fact, if you write continue in most code editors, it will show up as a different color than the rest of the words, just to let you know that, hey, this is part of the language. You can't use this word as a variable of any sort. And so what the continue keyword does is, all it does is, in the cases of a loop, it will skip that particular iteration of a loop, but then it will pick up on the next iteration. So here, if I have a loop and I start at I equals 1 and I say while I is less than or equal to 5, in the body loop, all I do is saying, hey, if I is equal to 3, continue, and then otherwise I console log out I is I. When I run this code, you notice like when I start at 1, right, is 1 equal to 3? The answer is no, so I skip lines 3 through 5. I go to line 7 and print out I is 1. Right, after I'm done with my code block, I go to my final expression, so I++, and now I is 2. I go to line 3, is 2 equal to 3? It's not, so I continue, and I console log out I is 2. Then I increment I by 1 again, now I is 3, and I say is 3 equal to 3? The answer is yes, so I go into my code block, I go to line 4, and I hit continue. What continue does is saying, great, just move from there directly to the final expression, or move directly from there to I++. And so when I do ++I again now, goes from 3 to 4. I check, is 4 less than 5? The answer is yes. So I go to line 3, is 4 equal to 3? No, it's not. So then I go to line 7 and I print out I is 4. And the same for 5 as well. And so eventually that's why we get the printout we see on the top right hand corner, and why we skip 3 is because when I is equal to 3, we hit line 4, and that says don't run anything else in this iteration of the loop. Go straight to the final expression and run the next iteration of the loop. And so what continue works in for loops as well as for loops as well. So continue basically just says don't run anything else after this part of the code block. Move on to the next iteration. And the reason why we have a continue is because we also want to contrast it with something called the break keyword. What the break keyword says is, hey, stop the rest of this iteration and also cancel all future iterations. So if I go back to the previous example here, the one thing that we said no, you really shouldn't do is on line 4, when I had a while loop and I have while equals true, well, organically that while loop will never ever terminate. Unless if I look in the body of the code, I see on line 7, it says, hey, if at any point my grade's length is equal to 3, so at any point if there's 3 letters in my grade, then I hit break. And what break basically says is, okay, stop running this iteration of the loop, and actually don't run any future iterations of the loop either. So break basically says end the loop right here now. Right? And so once again, the difference between a break and a continue is a continue says, hey, finish this iteration, but go to the next iteration. Break says, finish this iteration and don't run any other future iterations. You're completely done with this loop. And break also works for for loops as well as while loops. Any questions?
I do have a question. What are some of the real world uses for example, continue in a for or while loop? Like how will we use that exactly? Like
I mean, it's a tool. So like, let's say I have a list of people that I want to send a marketing email to, depending on if they've ever bought my product before, right? Like for each person I can do a check, right? And if they have if they have purchased this product before, then I use a continue and I skip to the next customer. If they haven't, then I could do a complex series of steps where I market something to them, right? Like I think as long as you know what it does, I think it's hard to kind of pinpoint like one specific use case. It's just like it's like a tool, right? But what break and continue really does is it tries to give you some measure of control while you're in the body of the loop to say, hey, if I want to stop right here, then I can stop. One of the reasons why people might also use break is because it's like if you're searching for something, maybe it's a lot more efficient. So let's say like I need to know if I have a list of like a million things, and I want to know if any of these things meet my criteria. As soon as I find the first match, I could just do a break and not have to search the rest of the million things, right? So there's also some kind of maybe potentially performance benefits, but it's more of a tool, and it's like like there's definitely use cases for it, but it's super up to like the user and the context.
Okay, thank you.
Yep. Any other questions on break and continue, or just loops in general?
I just have like one nitpicky thing on this break keyword slide, line 5. You
Yep.
got the triple equals symbol. Is that typically preferred over double equals? I think triple equals also checks to see if we're dealing with not only the same value but the same type.
Yep.
Um,
Yeah, totally.
why would triple equals be, let's say, preferred over double equals?
Yep. We'll actually cover this a lot more when we talk about coercion. But as a rule of thumb for now, so like we actually have a slide on this very topic. But for now, just as a rule of thumb for us in this class, you always want to use triple equals. You almost never want to use double equals. And it's just because triple equals is a lot more precise and it's a lot safer. And we'll talk about like what safety means when we cover the topic and coercion more in depth. Cool. Any other questions on loops?
Yeah, I have a question about while loops in the keyword do.
Mhm.
I've seen it used, I don't know if it's interchangeably with while or inside of a while loop.
Yep.
I'm just wondering if that's something we should be using.
Yeah, so a do while loop is not much different than a while loop. The only difference there is with a do while loop, you know how like with a while loop you could theoretically like start and stop right away if like the conditional is false. What a do while loop does, I think, is it does it at least once, and then it follows the same logic as a while loop. Right?
So a regular while loop doesn't necessarily ever have to iterate through the loop, whereas a do while
Yep.
does it.
It does it at least once. Yeah. Yeah, and like a do while loop is like it's helpful, but like honestly, like just from like a real life perspective use cases, you don't see while loops that often in the real world, just because like there is this theoretical chance that like you miswrite it and it goes on infinitely. You see for loops like the vast majority of the time. I'm not saying you don't see them, but I'm saying like it's just in general, I think people tend to feel safer using for loops. So if while loops seem a bit scary to you, like it is scary to developers too, and so that's why it's not as commonly used in general. Cool. Any other questions? Okay, awesome. Debugging. So the debugging section of the slide, I'm just gonna go through really quickly because I think honestly a lot of this is just practice, and I don't know if talking about it is gonna be super helpful. But just know that every developer, when they write code, the first time you run it, it always breaks. It never works the first time you try it. And honestly, if it does, it means something's broken because it never works the first time you try it. So if anything, if you watch developers, like if they write code and it works the first time, they get super suspicious and paranoid right away because it never works. So that also means you spend way more time fixing code than you do quote unquote writing it. So being able to figure out what's broken and how to fix it is incredibly imperative. And those two things are actually very different. So the way that we have it set up for you in your CodePen account is, remember earlier when I talked about like from now on every workshop you start when you run the code, the first time it will fail. Like that's totally fine. But the more important thing is, do you know why it's failing, right? And so the error messages actually, JavaScript actually gives decently good error messages for the most part. Like not always great, but definitely somewhat useful. And we'll cover a few of them. But essentially, like this screenshot you see on the right hand side of your screen, this is what you'll see a lot of when you do the workshops. Is like you start off and it's like, hey, I have 4 tests and 3 of them are failing. The more important part is underneath each test, it tells you what was the error it got, or basically, why did JavaScript not get what it thought it should get, right? And so there's a few common errors that you'll see. One the more common ones when you start off is something called the reference error, and that basically just means, hey, you used a variable that didn't exist, or at least you used a variable that didn't exist at the point in the way that you were trying to use it, right? So we talk about scope, we'll talk a lot more about like what it means to say it's the variable isn't in the right place. But for now, just kind of keep in mind, reference error means you're trying to use a variable that does not exist. Okay. And not only does it tell you that, so in this case, on the right hand side, we not only see that the problem is a reference error. Hey, this variable called sum does not exist. It also shows you kind of how it got there, right? A lot of the so like what you see down there, lines, I guess kind of lines 12, 13, and 14. What they do is they actually tell you the sequence in which the computer ran the program until it got to the error. And so line 14 ran first, then that ran line 13, which then ran line 12, which finally led you to the error on line 11, so to speak. And so it works its way from the bottom up. And so if you see that, reference error sum is not defined, if I look right beneath it, it actually says, oh, it tried to use a variable called sum in the only odds function on line 11, column or character 7. Usually the character doesn't matter as much. Usually you just care about the row number. But that at least tells you kind of where the code was trying to use sum and where it failed. And so this is what we call a stack trace, which basically means we not only give you the error, but we help you trace along the path to see how you got to the error. Reading this is more of an art than a science, and I think over time you'll just get more experience over kind of figure out like, hey, if I get a certain error, where does the code is broken? Just know that the error does not always happen in the same line where it's being caught, right? Like I'm trying to think of an analogy here, right? But let's say let's say I was supposed to mark someone's ticket, right, on a train. Well, if I marked the ticket wrong, technically speaking, the error occurred when someone bought the ticket and I gave them the wrong ticket. But that error is not going to surface until maybe much later when they're on the train and the conductor asks them for a ticket and the person gives the conductor the wrong ticket, right? So just because the trace says, oh, we caught an error here, don't think automatically it means that's where the error is, right? Actually try to understand what's going on, why that error happened, and then think back to say, okay, where could the error have been caused, right? So in the example I gave, if a customer gave a conductor the wrong ticket, the train of thought is not like, oh, the customer had many tickets and he gave the conductor the wrong one. It's more like, oh, like what would cause a customer to have a wrong ticket? Oh, well, maybe at the ticketing booth they purchased the wrong ticket or they were given the wrong ticket, right? So it's less about like kind of mechanically going there and saying this is the error, and more trying to understand what actually happened. Failing tests. There's a few ways tests are going to fail. The two main buckets I would say are important to us are, one, the test failed because the code is faulty in some way and it didn't run, right? We used variables that didn't exist. We forgot to put a curly brace or a parenthesis somewhere, and there's an error and the code cannot run. The second type of error is saying, hey, the code ran, but it gave you not the right answer, right? So if I had a function that was calculating the average of 3 numbers, well, the code could very well run, but it could give me the wrong number, right? It could say the average of 0, 1, and 2 is 6. And in that case, it would be giving, well, I guess not that, but like in that case, it'd be saying like, okay, the code ran, there's nothing wrong with the syntax, but it didn't give me the right answer, so there's some logical failure there too. And so that's what you see here, right? When you say something like expected x to equal y, it just means, hey, the test was expecting this and it got this instead, right? So that tells you your code is not wrong syntactically, but there is something wrong with it logically. And then lastly is when you look at your test, sometimes the name of the test also gives you a good guidance as to what you're trying to look at. In this case on line 10, it says only odds, the function only returns a number, and it says it got back undefined to equal number. That just means, hey, I expected to get a number back and I got back undefined. So it probably means in your function you forgot to return something, right? So the name of the function, the name of the test can also be very helpful in trying to figure out what's happening and what's not. This basically is a shorthand for saying just look at the test to understand what the test is trying to do, and it should give you some more guidance on like, maybe why your test doesn't work. This is something that as you work through the CodePen workshops, like once you're comfortable writing the code, also look at the test to figure out what's going on, because that's going to also give you some good guidance on what they're trying to get at. Yep, all the tests are just JavaScript, so there's nothing wrong. The debugger and VS Code, this part I'm not going to go over nearly as much. If you want to read these slides on your own, feel free to. These slides should be up. If they're not, let me know. But what it does is they're just tools that you can use to pause code and run it one step at a time. But like it works well in Chrome, but it's also like a bit complex to pick up. And for our purposes, I actually think it's much better if you, as you read the code, to actually understand just logically what's going on and work your way through that, rather than trying to introduce you to a whole new set of tools that actually probably make it things more confusing right now than it does help it. At some point, this will be helpful to you, but I don't think right now is like a good place to kind of get you stuck in like the Chrome DevTools world. But there are things that actually help you run code and then stop at certain points and try to figure out what's happening at each stage. The good news is what we're doing right now is not super complex, and most of it you can just run through it, like run it through and figure out what's going on the fly. So yeah, so the debugging thing, once again, these are just like small kind of almost tips. They're not like core things that you need to know. Like you'll encounter all of these as you go through the workshop. But yeah, any questions on loops, I guess primarily?
Less of a question on loops, but more of a. You said that the slides would be on LearnDoc.
Yeah, they should be. Are they not?
Not from what I can see.
Okay, so when you go to like, so for example, when you go to loops and debugging, right? When you go to this page here, can you click on the boot image? Does that take you anywhere?
I see pre-recorded lecture.
Right. Sorry. So click on the image above that, like the picture of the boot.
Oh. Pre-recorded lecture, workshop, and feedback.
No. Okay. So do you see the big picture of the boot above those three things?
It's not above. It's to the right.
Oh, okay. Is it clickable for you?
Yeah, I clicked it. So when I was above, I clicked it, and then it took me to the page that I just stated. And then I saw pre-recorded lecture, workshop, problems, and feedback. And then now the boot is to the right, but it doesn't have a link attached to it. It's just an image.
Sure. Actually, so sorry. Okay. So before we do this really quick, any other questions on concepts on loops? Okay. I'm gonna stop the